Did you know that the product of two positive integers that can be written as a sum of two squares can also be written as a sum of two squares? What? For example, 13 can be expressed as 2 squared plus 3 squared, and 25 can be expressed as 3 squared plus 4 squared. 25 times 13 is 325, which itself can be expressed as 6 squared plus 17 squared. Cool, right? The proof is as follows. Consider these two complex numbers, z1 and z2. z1 is a plus bi, and z2 is c plus di. Let's consider the square of their moduli. So as you can see, the square of the modulus of z1 will be a squared plus b squared, and the square of the modulus of z2 will be c squared plus d squared. Let's now go ahead and form this product, which represents the product of our two numbers that can be expressed as a sum of two squares. Now that product can be expressed as the product of the squares of each moduli. But factoring out the square, we get that, which is equivalent to the square of the modulus of the product. I'll leave that for y'all to prove. But now we just find the product of z1 and z2. That will give us that. And now taking the square of the modulus of that complex number, we get the following. AC minus BD quantity squared plus AD plus BC quantity squared, which as you can see is a sum of two squares. So we have now successfully shown that the product of two positive integers that can be expressed as a sum of two squares can itself also be expressed as a sum of two squares. In fact, the nice thing about this proof is that it gives us a way of finding those two integers that would square and sum to our product. You can use our example earlier to verify this. But yeah, I think that's a pretty cool fact. Now there's a similar result for a sum of four squares, but I'll leave that for another video. With that, I hope you're doing well. Make sure to hit that follow button for more math content. And as always, I'll catch y'all in the next one. Take care.